Example 1 says find the reference angle alpha for each given angle theta in these four examples. So before we do that, the reference angle alpha of any non-quadrantial angle theta in standard position is the acute angle between the terminal side of theta and the x-axis. And angle alpha is always considered to be a positive angle less than 90 degrees. And so what that means is that we have an angle theta. We have the initial side and the terminal side of that angle. The angle alpha is the angle between that terminal side and closest to the x-axis, meaning that alpha always has to be less than 90 degrees but greater than 0. And so in this example, from the positive x-axis to the negative x-axis is 180 degrees. If theta occupies 140 of that, alpha must make up the remaining 40 degrees. So in part A, alpha is equal to 40 degrees. And notice we always consider alpha to be a positive angle. There's no indication as to whether this is a positive or negative. So we call that the reference angle. In part B, theta is 72 degrees. And so here's our terminal side. And alpha must be less than 90. It's the angle between that terminal side and the nearest part of the x-axis. And so theta, in this example, is also 72 degrees. Right, so here theta and alpha are the same angle. And part C, theta is 215 degrees. We want to know the angle between the terminal side of that angle and the nearest part of the x-axis. And so the negative x-axis is 180 degrees. And so if we're looking at 215, then alpha must be the difference between 215 and 180. Right, so 180 takes us to the negative x. How many more degrees do we need to go to get to 215 altogether? And so the answer is 35 degrees. And so that's what alpha must be. In part C, alpha must be 35 degrees. Now in part D, we have an angle that is 670 degrees. So it goes all the way around once, which is 360 degrees, and then it goes almost all the way around again. Not quite though. 2 times all the way around would be 720 degrees. Right? So 2 times around would be 720 degrees. And so 2 times around would take me all the way back to the positive x-axis. But I didn't go quite that far. I only went 670. And so if I find the difference between 720 and 670, which is 50 degrees, that is what alpha must be. Alpha must be 50 degrees in part D. So let's look at how the reference angle looks in each quadrant. If theta were in the first quadrant, and we had an angle theta, then theta is equal to alpha. Right, so if theta is less than 90 degrees, but it's greater than 0 degrees, theta and alpha will be the same angle. But if the theta angle was in the second quadrant, if it's over here somewhere, then the reference angle, alpha, will be whatever 180 degrees is, take away theta, and that leaves you with alpha. So in the second quadrant, let me summarize here. In the first quadrant, theta is equal to alpha. But in the second quadrant, alpha will be equal to 180 degrees minus theta. So again, if you have 180 degrees and you take away theta, what is left is alpha. Right? So 180 minus theta is equal to alpha. In the third quadrant, the angle theta is in the third quadrant somewhere. It's greater than 180, but less than 270. And so alpha is going to be this angle. And so we would take whatever theta is, subtracting 180 leaves you with alpha. Right? So whatever theta is, if you take away 180, what is left is alpha. So alpha will be equal to theta minus 180 if we're in the third quadrant. If we're in the fourth quadrant, we have an angle down here somewhere. 360 takes you all the way around. And if you take away whatever theta is, what is left is alpha. Right? So here alpha is in here somewhere. So alpha will be 360 degrees minus theta. And so we want to make sure that we can calculate alpha. If we know what theta is, we know which quadrant theta is in, we should be able to calculate alpha from that information. This is example 2. It says find the sine of negative 114 degrees. Also find the secant of 250 degrees. And so first let's look at the angle on the coordinate plane. And negative 114 degrees means we start at the positive x-axis and we're going to rotate clockwise because it's negative. It's greater than 90, so it's down here somewhere. So this angle theta is negative 114 degrees. Now we can just simply type this into our calculator. And so we will type in the sine of negative 114 degrees, and we get negative 0.9135. Negative 0.9135. That'll be the sine of theta. Now the secant of 250 degrees, that's a little bit different. So if we start here at the positive x-axis, that's 0. Here's 90, here's 180, 270 is down here, 250 is right in here somewhere. Not the same angle, but they look like they're close. So here's 250 degrees. Now your calculator probably does not have a secant button, right? And so we've seen examples like this before. We need to remember the relationship that secant is the reciprocal of the cosine, meaning that the secant of 250 degrees is the same as 1 divided by the cosine of 250 degrees. Right? So in order to use your calculator to find secant, you have to remember that it is the reciprocal of the cosine. And so we'll type in 1 divided by the cosine of 250 degrees, and we get negative 2.924. So the secant of 250 degrees is negative 2.924. This is example 3. It says sine theta equals 0.4772, and they want us to find theta. And they want us to make sure that we get an answer for theta that is greater than 0 degrees or equal, but less than 360 degrees. So in other words, they want the angle to be positive, and they don't want it to go all the way around in a circle more than just one time. And so we can use our calculator to do this. We know that if we know that the sine of the angle is equal to some number, we can find the angle by taking the inverse sine of that number. And so we'll type that in. The inverse sine of 0.4772 is equal to 28.50. Theta is equal to 28.5 degrees. Now, this is not actually theta. When your calculator gives you an answer for the inverse sine, inverse cosine, or inverse tangent, your calculator is always giving you an answer for alpha, the reference angle. And so, what does that mean? If we look at a coordinate plane, we first must consider whether sine of an angle was positive or a negative value. Remember that the sine of an angle is positive in the first and the second quadrants. And your calculator is giving you an answer for alpha. And so that means that there are two possible answers. They're in the first and second quadrant. One of them is alpha equals 28.5 degrees in the first quadrant. The second answer is alpha is also 28.5 degrees, but in the second quadrant. And so in the first quadrant, alpha is equal to theta. And so there's two answers. One of them is that alpha, or theta, is equal to alpha in the first quadrant. So theta could be 28.5 degrees. But also over here in the second quadrant, remember that alpha is equal to 180 minus theta. And so we've been given the answer for theta, 28.5 degrees, and we want to find theta. So we need to add theta to both sides. so that it will be positive. And then we need to subtract 28.5 from both sides. So these cancel, and we get theta equals, and 180 minus 28.5 is 151.5 degrees. And so the other possible answer for theta is 151.5 degrees. And so there's two answers. Theta is either 151.5 or theta is 28.5. And so we're saying that the sine of theta is equal to 0.4772. We're saying that the sine of 28.5 is equal to 0.4772. But we're also saying that the sine of 151.5 is also equal to 0.4772. And so let's check our answers. The sine of 28.5, and I rounded my answer, but is 0.4772 rounded, and so that's correct. But the sine of 151.5 is also 0.4772. So anytime you're using your inverse trig functions, you have to be aware that you're always going to get two possible answers. This is example 4. It says tangent theta is equal to negative 0.3172, and find theta for theta is greater than or equal to 0 but less than 360 degrees. So again, they want a positive answer that's less than 360 degrees. And so the tangent of the angle, we're looking for the angle. The tangent of the angle is negative. Remember that the tangent of theta is equal to y over x. Now there's two ways that we could get a negative answer. Either y is negative and x is positive, or y is positive and x is negative. And so if we look at the coordinate plane, in order for the tangent of theta to be a negative number, the answer must either be in the second quadrant or the fourth. That's where y is positive and x is negative. When we divide them, we'll get a negative number. Or x is positive and y is negative. Again, when we divide them, we'll get a negative number. So we're looking for answers in either the second or the fourth quadrant. So we know that we can find theta by taking the inverse tangent of negative 0.3172. We can use our calculator to do that. So we'll find the inverse tangent of negative 0.3172, and we get theta is equal to negative 17.60 degrees. Now, that is against the rules. We want theta to be greater than 0, but less than 360 degrees. And so, what our calculator is telling us is that the angle is a negative 17.60 degrees. We need that angle to be positive. And so what we'll do is, if this angle is negative 17, if we add 360 to it, we'll get back to the exact same position, but we'll have an angle that's positive. So we're going to add 360 degrees, and we'll say that theta is equal to negative 17.6 plus 360, and we get 342.4. 342.4 degrees. And so we don't want negative 17.6 degrees, we want a positive 342.4 degrees. But we still have the problem of finding the other angle. What is the other angle? And so you can find the other angle by subtracting 180 degrees. As it turns out, for tangent, the reference angle from the x-axis to the angle that we're looking for is going to be the same in the second quadrant, right? So the reference angles alpha are going to be the same. If we add or subtract 180 degrees from one angle, we'll get the other. And so the other possible solution for theta is 342.4 degrees minus 180. And so we have 342.4 degrees minus 180. The other answer is 162.4. Okay, so let me draw this a little better. We have two answers. We have 162.4 degrees, and we also have 342.4 degrees. So we think that the tangent of 162.4 should be equal to negative 0.3172. We also think that the tangent of 342.4 degrees should also be equal to negative 0.3172. And so let's check our answers. The tangent of 162.4 degrees is negative 0.3172, and the tangent of 342.4 degrees is negative 0.3172. And so again, there's always going to be two answers. If you have to use the inverse tangent to find an angle, you're always going to end up with two different answers for that angle. This is example 5. It says the cosine of theta is equal to negative 0.2405. And find theta. Again, theta needs to be greater than or equal to 0, but less than 360 degrees. So remember that cosine of theta is equal to the x value over r. The x value must be negative to give us a negative answer because r is always positive. And so when you look at the coordinate plane, the x values are negative in the second and the third quadrant. So we know we're expecting two different answers. There's two different possible angles that give us this answer. And so we can use our calculator. Theta will be equal to the inverse cosine of negative 0.2405. And so we'll use our calculator. The inverse cosine of negative 0.2405 is 103.916. Theta must be equal to 103.916. And so that's one possible answer. That's a second quadrant answer because it's greater than 90, but it's less than 180. So we're looking at an answer somewhere over here, greater than 90 degrees. The other answer has the same value of x, but you can tell that the angle is greater than that. So this angle is 103.9. The reference angles are equal. And so what is the reference angle here? The reference angle will be 180 minus 103.9. And so our reference angle is 180 minus 103.9. The reference angle is 76.1 degrees. And so that must be this same reference angle. So the second theta must be 180 plus that reference angle, right? So our second possible answer must be 180 plus our reference angle, 76.1 degrees. And so our theta will be, looks like 156.1 degrees. And so we think that the cosine of 103.9 should be equal to negative 0.2405. We also think that the cosine of 156.1 degrees is also equal to negative 0.2405. And so let's check our answers. The cosine of 103.9 is negative 0.2402, and there's a little bit of rounding error because we rounded our answers. Also, we think that the cosine of 156.1 is also, oh, I must have made a mistake. Let's see, did I make a mistake? 180 plus 76.1. Oh, I'm sorry, it's 256. 256. Let's try that again. So we think that the cosine of 256.1 degrees is also negative 0.2402, and again a little bit of rounding error because we rounded our answers. So keep in mind, anytime you use inverse tangent, cosine, or sine in your calculator, you're going to get a single answer from your calculator, but there's actually two different answers. This is example 6. It says the cotangent of theta is equal to negative 1.650. Find theta, and we need theta to be greater than or equal to 0 but less than 360. And so recall that the cotangent of an angle is equal to 1 divided by the tangent of that same angle. And since the cotangent equals negative 1.650, 1 divided by the tangent must also equal negative 1.650. And so we need to solve this equation for tangent theta. Right, we need it to be out of the denominator, so we'll multiply both sides by tangent theta. We get 1 equals negative 1.650 times the tangent of theta. And then we'll divide both sides by negative 1.650. And so we'll get the tangent of theta is equal to 1 divided by negative 1.650. Now recall that the tangent of theta is equal to y over x. And so when the tangent of theta is represented as a fraction this way, we're getting a point that falls on the line of the terminal side of this angle. And so if we look at the coordinate plane, we can treat 1 as though it's the y value, negative 1.650 as though it's the x, and this is one of the angles that we're looking for. And the negative doesn't necessarily have to be in the denominator, because as long as the signs are different, when we divide them we still get a negative number. And so the y value could be the negative 1, and the x value could be a positive 1.650. And so tangent of theta could also be negative 1 divided by a positive 1.650. If you divide these numbers, you'll get the same answer for both. And so we could treat this as though this is the y and the x coordinate, where x is positive 1.650 and y is negative 1. And so we could be getting an angle like this as well. Right? So these are the two angles that we're looking for. And so we want to find theta. Theta will be the inverse tangent of negative 1 divided by 1.650. And it doesn't matter which one I use here. My calculator will give me the same answer. It doesn't matter where the negative is. And so theta equals, we use our calculator, the inverse tangent of negative 1 divided by 1.650. Oops. Let me try again. The inverse tangent of negative 1 divided by 1.650, and we get negative 31.22. Negative 31.22. And so that is not actually theta, that is alpha, the reference angle. So remember, anytime we use the inverse trig functions on our calculator is telling us alpha. So negative 31.22, that is one of the reference angles. And you can see that if we add 180 degrees, these lines are is a straight line, so they're 180 degrees away from each other. If we add 180, that will give us theta. Theta will be negative 31.22 plus 180. And so we get negative 31.22 plus 180. And we get 148.78. Right, and so that's this angle. 148.78 degrees. The other angle, because I need it to be greater than 0 but less than 360, right, I don't want this negative reference angle, I'll add 180 again. And so the other answer for theta will be 148.78 plus 180 again. And so we get 148.78 plus 180, and we get 328.78. And so these are our two possible answers for theta. At least that's what we think. We should check our answer. And so we know that the cotangent of theta equals negative 1.650. That means that 1 divided by the tangent of theta, and we think theta is 148.78. We think that this should be equal to negative 1.650. And also 1 divided by the tangent of 328.78. We think that this should also give us negative 1.650. So we think these are our two answers. Let's check. Take 1 divided by the tangent of 148.78, and we get negative 1.649 8, which rounds to 1.650, negative. Also 1 divided by the tangent of 328.78. And again, we get negative 1.6498, which rounds to negative 1.650. So these are our two answers for theta.